Yeah, hello all, good morning, good evening. So today I'm going to explain about the system bottleneck, right? If you are aware, in last session I was explain about all most of the topic, right? Uh, which one related to bottleneck, where is actually bottleneck. Total five stages was the bottleneck, right? If you remember, I was explain about the source, target, source, right? Mapping level, right? And then transformation, then this one is a system bottleneck. System bottleneck basically, why we are saying the system bottleneck, where is actually happen the system bottleneck. This system bottleneck is the main role here, is the main source, right? Suppose your system is not working, right? Then how your mapping and ETL is process, right? Source to targets, nothing happen, right? That's what system bottleneck also need to identify. If some cases your mapping is taking huge time, start a huge time, then total five key things need to check one by one. Suppose if you, yeah, first you need to like target, source, then mapping, then yeah, right. So you need to check it sequence wise so that we can take all. But yeah, you need to check entire thing. Otherwise, you can't identify. So yeah, so how system, if you are aware, right? After in last session, right? How I was explain in last session I was explain about after you tune, right, multiple things, right? So multiple thing you explain after you tune the source, target, mapping, and the session. So consider the tuning the system to prevent system bottleneck. Correct? So the integration service, Informatica having the integration service, right? Everything, every process was happen via IS. Okay. So service uses system resources, right? Resources mean entire processes like remove, CPU utilization, RAM, yeah, everything. So that's what here is telling the system. It will uses system resources to process transformation, right? How many transformation we have written, that transformation they take, you use the system reset, then start the processing. After that you run session, right? And read and write data. Once you read the data from source, then write data in the target. Correct? So the system integration, the integration service also uses system memory, right? Why they, I told the system memory they use, because to create the cache file, because if we are not going to always in database read, they store some data in cache memory, so that if any calculation required, they can directly go in cache memory and use and start calculation process. So in that case, the files for transformation such as aggregator, joiner, who is the multiple transformation having a cache information, they can configure and they can use accordingly, right? Here is some sample transformation name mention, right? That name is like aggregator, joiner, lookup, and XML and rank transformation. Correct? So these are the information, right? So how to identify the system bottleneck? There is some process how to identify. So you need to check, right? What will the process you need to check, how to identify the system bottleneck. You can view, right? How to view? You can view the system resource. Okay, usage in the workflow monitor. There is some workflow, right? You can go where you are monitoring. Suppose you executed any workflow, then you can view the in monitor. There is monitor some in bottom. If you notice, there is a source, target, their throughput, how rows affected, that kind of information there. So you can cross check. You can use the system tool to monitor a window and a Unix system, right? Suppose your system was installed in a Unix window, then you can monitor in window. Otherwise, if your system was means Informatica was installed on a Unix system, you can monitor accordingly your system. There is no any concern where you install, you need to validate accordingly. So using the workflow monitor, you to identify system bottleneck. Okay. So you can view the integration service properties. What are the properties? There are multiple properties there. Okay. So some property like workflow monitor to see CPU. Okay. Here is CPU, then memory and swap usage of the system when you are running task process. Correct. On the integration service, use the following integration service property to identify performance issues. Here is the some issue properties which can read, and what are the property? First property, like CPU percentage. How much percentage of the CPU you need to uh, identify the percentage, like percentage of CPU usage, just like include other external tasks, right? Suppose you write some command, right, on your server, when you open a putty or something, right? Then you identify how many CPU utilization there, how many memory, how many swap uses. So that kind of information you can cross check, right? How much memory percentage you are using your particular task, right? And also you can cross check, like maybe some other unnecessary task is running at that time. That one also a very important part, right? So in that case, here is memory usage. The percentage of memory usage includes other external tasks running on the system. Correct? What I'm saying. If the memory usage is close to 95%, okay? If close to 95%, then check if the tasks running on the system are using amount of indicated in the workflow monitor, or if there is a memory leak, right? Is there memory leaking somewhere? To troubleshoot this part, use system tool to check memory usage before and after. Okay, suppose when your task not executed, then that time you can check. After when you executed the task, then you can cross check and then compare the result of the memory usage while running the session. Correct? So in that case, you can validate the memory usage so that you can identify the how much memory you're using by your particular task. So in next point, I need to explain like swap usage. Suppose swap usage is a result of paging, right, due to the possible memory leak or a higher number of concurrent tasks. Okay. So in that case, now on next point is identifying the system bottleneck on Windows. Suppose you must Informatica was installed in Windows, right? Suppose you have someone developer, or maybe they're not using Unix by small company. They are using the Windows. Then there you can build it by some guys who was working on Windows machine. Then they are can validate how their side he need to build it. Same way, kind of, you can use the performance and the process tab in the task manager. There is some task manager for system information. The performance tab in the task manager provide an overview of CPU usage and the total memory used. Okay, use the performance monitor to view, okay, the detailed information. Correct. So the following table describe the system information that we can use in the Windows Performance Monitor to create a chart. So here some chart I was prepared. Okay, that chart is showed to complete detail information, chart and description, right? So what is the property? Property, there is percent process time. If you have a more one CPU, right, more than one CPU, then monitor each CPU for percentage process time. Okay, processor time. So second point is page per second. So if page per second is greater than 5, you may have a excessive memory pressure known as thrashing. Correct. So what is the physical disk percentage time? The percentage of the time that the physical disk is busy performing read or write request. So in this point also you need to check like physical disk percent time. Okay, so second third point is okay, like physical disk percentage. Now fourth point is just physical disk queue length, right? So in this case the number of user waiting for access to the same thing, maybe some task is set in pipeline and waiting. Once it is free, then you start writing there. So in this part you can check that one also. Okay, so last point is just like a server, total bytes per second. Okay, so the server has the sent to and received from the network. The server has sent and received some part. Suppose you are requesting, right, so that part they're sending some information to via the network. So there also sent and received process also involved. So you need to check that property as well. Okay. So next point, I need to identify the system bottleneck in Unix. How to identify Unix area? Same way by use the following tools to identify system. Which tool? Like top. if you open, there is some command. Okay, so if you open your Windows Unix, right, Unix cell putty open, and just go in a server and just write the command, the view overall system performance, right? If you write this command, if you can view overall, this tool displays CPU usage, memory usage, and swap usage, all right, for the system and the individual process running on the system. Suppose you have executed your task, that particular task also you can view. So this is the main command. You can write directly and you can validate. Second command, IO-stat. IO-stat is actually the monitor the loading operation for every disk attached, right, to the database server. So IO-stat is actually display the percentage of the time that the disk is physically active. If you have used disk array, use utility provided with the disk array instead of IO state. So this information, this part also we they provide us. So what is the monitor, right? How to loading the every disk attached, right? Suppose we are the rack and something, we are multiple huge data, right? So we are attaching this kind of disk, right? So how the IO state display the percentage of time that the disk is physically active or not, right? If you use disk array, use utility provided with the disk array instead of IO state, correct? Next is the VM stat. So in that case, monitor disk swapping. Suppose you are swapping the disk from one to other, that part also you need to check by this way. Okay. Now, last command is SAR. So SAR is actually the view detailed system activity report of CPU, right? So if you execute this command in your Unix, then you can view the detailed system activity, right? What is actually running in behind the CPU, memory, disk, and disk usage. Okay, where is actually utilizing, how, what is the process, complete picture you can view, right? So you can use the tool to monitor CPU loading, right? It provide percentage usage on user system and ideal time and waiting time, correct? So you can view, so you can also use the tool to monitor disk swapping action, correct? So these are the tools, right? Some command, right? This is command you can write and validate an Unix prompt so that you can check in runtime what is the happening on your server, correct? Now this point is eliminate, how to eliminate system bottleneck, right? So elimination of the process, like complete the following tasks to eliminate system bottleneck. How? If the CPU usage is more than 80%, suppose your utilization is more than 80%, check the number of concurrent running tasks, right? What I told you, you need to cross check, right? Along with your task, maybe some other tasks also running. That's what your utilization increasing, going at greater than 80. So in that case, you consider the changing the load or using a grid to distribute the task to differentiate different node, right? If you cannot reduce the load, consider adding more processor. If you cannot reduce the load, then you need to add the additional processor so that your process can execute as usual. So, and second point is, third point is, if swapping occurs happening in increase the physical memory or reduce the number of memory incentive application on the disk, correct? If you have excessive memory, right, memory pressure thrashing, right, the consider adding more physical memory, right, rather than this. Okay, so if the percentage, last point is actually, last point is, if the percentage of time is high, suppose your percentage of time is high, the tune and cache of power center to use in memory cache, right, instead of writing to disk, right, like buffer memory, right? If you tune the cache, requests are still in queue and the disk busy percentage is at least 50%. Why they say, suppose you are writing some query, right, unnecessary, without where clause, without filter, to unnecessary your cache is increasing every time. So if you filter out, you can just filter out only just necessary record you can use per cache as well, so it will be reduce your percentage of usage, right? So add another disk device or upgrade to faster disk device, right? So you can also use a separate disk for each partition in the session, right? So these are the all about the how to eliminate right system bottleneck. Okay, so if physical disk queue length is high, is greater than 2, right? So consider adding another disk device or upgrading the disk device, right? So you also can use separate disk for reader, writer, and the transformation thread. So why here they are trying to tell, okay, suppose your huge information, right? So you can just differentiate, right? So you can differentiate the thread by each process, reader, writer, and transformation, right? So consider improving network bandwidth when you tune Unix system. Tune the server for major database system. If the percentage time spent waiting on IO, right, is high, consider using other utilities. For example, if the source data, target data, lookup, rank, and aggregate cache file are all in the same disk, right, consider putting them on a different disk. So we can distribute, right, everything. So if you differentiate everything, it will be load can be distributed and your process can execute as usual. Okay. Yeah. So these all are about the system bottleneck. So you can just watch carefully and just read, right? If any issue, anything, if you found like not understand, you can just comment out. I will try to explain again in next session. Yeah. Thanks for watching. Just keep safe and just keep watching. Just subscribe, like, and share so that I can improve, right? So that everyone can take the advantage with free this kind of channel. Okay, yeah, thanks for watching.